Hey there, everybody. This is the next lesson in our statistics unit. We're looking at sampling techniques, but before we get to that, let's do a little review of the distribution types. So press pause if you want and select which each one would be. We'll move uniform somewhere, normal or bell curve somewhere, left skewed and right skewed somewhere, and bimodal somewhere, possibly for each one of these. We'll see what numbers we have and so on. Hello. That's okay. I'm just doing a video over at Skype. All right, so hopefully you've chose uniform distribution for that one. Normal bell curve is down here. Bimodal is pretty obvious, and this one here, remember the tail goes way off to the left, so that's left skewed. Right, there wasn't a right skewed there at all, so maybe I'll just delete that one so it's not on the note going forward. All right, so when we're getting data, what's called sampling. So sampling, we'll see this in a second here, but it's when you're picking people from a large population to get data from, or answers to questions, or you might be measuring their heights, or whatever the case may be, right? So it could be continuous or discrete numerical data, or it could be categorical. So here's just an example just to get us thinking about things. So Natalie surveys randomly in quotes, because we need to talk about that. Random sampling is not as easy to do in practice as you might think. But anyway, so she's trying to randomly sample from her online youth book club members, as well as the list of people that are card holders from the community libraries. Okay, so she's returns to school and suggests to her friend on student council that the school should host a readathon. That's the question they're asking. Should we host a readathon to raise money for prom? And so everyone in the survey felt it was a good idea. So she's presenting this to student council saying, hey, this should work. And so the question is, what's the problem with her research? So hopefully you're recognizing here that she asked a bunch of people that are part of a book club and regularly go to libraries whether they think a readathon is a good idea. Obviously, you wouldn't be talking to people that aren't interested in books, right? If you're doing that. And so it's a very biased sample. You're taking a sample from a population that really contains all of the people that are into that sort of thing, right? So just from, where was I here? Google search here. I was just looking at just trying to show you bias sampling. Like not everything comes from Wikipedia, but basically I wanted to get wording about bias sampling. And it says just where you have some of the members in an intended population have higher or lower amounts or numbers of them in the population. So higher or lower probability than others, right? So obviously here in this situation, where am I? Here we go. In this situation described here, obviously there's a way higher chance of picking people that are very into reading books versus people that are not. Okay? And so, so the advantages and disadvantages of sampling, right? That's one of the disadvantages. You can end up with biased samples if you're not careful. And obviously, if you sample the entire population, you're going to get really accurate results for the whole population, but that's really hard to ask everybody, especially in large populations, right? If you are sampling everybody in a population or trying to, then that's actually called a census. And the government does that every once in a while. There's a census year and you get this booklet in the mail and a whole bunch of questions, and you legally are required to answer those questions. Census. Everybody answers it. So obviously a biased sample would mislead your results about your predictions about the population. Okay. So like I said, when we were talking about it there, the population of high school students, in the population is all the high school students. The sample is the group of people that the person chose to survey, which was just people in the book club and people that use library. In general, the population, it's the entire group, of course, right? And the sample is a portion of that, of course. So sampling techniques, random sampling. So all selections are supposed to be equally likely. So drawing names from a hat or things like that, right? So it's easy to do in quotes, but I'm going to talk a little bit more about the fact that it's harder than you might think, right, to do that. And there's also, of course, the chance, random chance. Like if you flip a coin 5 times, could you get 5 heads in a row? Yeah, you could. And so you could end up with a poor representation of the population just by random chance. It doesn't usually happen, but it's something to watch for. That's pretty much the cons in most of these cases. If you like, it could end up not representative, but you kind of have to trust random sampling at some point, and you just have to make sure that you are doing it well. So, like I said, random is harder than you think, especially for computers. Computers are designed to do predictable processes only, right? So, generating random numbers is actually trickier than you think. And so, there are random number generators on the internet for that reason, right? It's also hard for humans, right? So, say you're trying to pick cars at random in a parking lot, going around just tabulating how many cars, and you're going to pick 100 cars or count 50 of them or whatever. You have to do something so that you're not saying to yourself without even thinking about it, gee, I just picked 3 gray cars by chance in a row, so I better skip the next gray car if another one comes up, and try to balance that out. Like if you even without thinking about it, your human brains do that, right? Human brains are designed to try to make patterns and make things right when you're doing things. Okay, so you got to watch for that. The next couple of slides I have here are about a neat thing that exists in our world called Lavarand. And Lavarand is this company that works with internet security encryption processes. And so for encryption, you need to have unpredictable random sequences of numbers that you use as a key for the person to decode the information that got sent. So if information gets intercepted by someone, they're not able to do anything with it if they don't have the key. And so currently, actually, everybody just uses data from measurements in the surroundings, like the temperature and this unpredictable kind of random things. But they have this wall of lava lamps that are extremely random, and so that's their source of that's their backup source of unpredictable random key number generators for encryption processes. So it's worth a little read through there, I would say, about this. They talk about how if you send this message, the rain in Spain stays mainly on the plane or whatever, then people know, like, oh, okay, for choosing a movie, that means you chose heads, and so that's the movie, and so or whatever you watch movie that to do with heads, coin flip, and so on. And so basically, you flip a coin, and then you send this message about what your movie you're going to watch, and they use the code that you sent as a way to decide which version of things it was. So read through it. I'm not doing a great job explaining it, but I think it's a worthwhile little read, and it has kind of to do with at least that my information about randomness being kind of hard to generate. So a friend of mine told me about this thing, so I included it. He led me to believe that the random numbers are actually coming from lava lamps. But when I read through it, it's actually they have the lava lamps as like a backup plan if needed, but it hasn't been needed yet apparently. So interesting. Systematic sampling. So one of the ways would be just like in the parking lot, just count 1, 2, 3, 4, 5, 5. Every 5 cars, that's the one you're picking, regardless of the color. Something like that, right? So sampling every 5th person and so on. Super easy to set up. Could lead to a poor representation. It could, but by random chance, you kind of have to just trust it. Judgment sampling, and so this is where you choose a sample based on their knowledge of the population. So it's hard to explain other than just using an example. So if you're looking for opinions on cars, you're going to go to like auto mechanics, for example, because you trust their judgment on the cars more than just the average Joe. So easy to set up, of course. It might be biased if you went only to, say, Chevy dealerships. They might be more likely to say that Chevy is a good brand or something like that, or maybe they know stuff you don't and say don't buy Chevy. Who knows? Right? Probably not though. Stratified samples. So it's when you break the population into groups, and then a random sample is taken from the groups. So for example, here the school is divided into 4 groups by grade, and then you just take samples from each of those groups, right? So 30 grade 9s are surveyed, and not sure why. Oh yeah, then you're taking the percentages. So you survey the appropriate number from each one to represent the overall population. So it's more likely to get a fair representation, right? It's less likely that you're not going to by accident survey a bunch of grade 9s by random chance. So it takes time to set up, of course, got to put some thought into it, but yeah. Cluster samples. So just the population divided into groups. Groups are chosen at random to be sampled. Again, that's an issue there, right? But and then all members are chosen from that. So you try to set up groups and then just ask everybody from there, right? So a house team during the fun day was asked to respond to a survey, and the house team presumably is just sort of a random sample from the school itself, right? So you just take advantage of these groups that already exist, possibly. So convenience sample, right, is just basically, to survey woodworkers in Ontario, ask several people, woodworking store, for example, or whatever, around the province. Like it's just a way to get information about that group. You just go to where that group is. You see a car show at the Canadian Tire parking lot on a Friday night, go there and ask about muscle cars or something, so you have people there that are interested in that, that topic or whatever. And then voluntary sampling is a pretty obvious one too, right? Where you just have a survey sent out to a wide range. It could just be at the library, it could be a poster looking for volunteers kind of thing, right? And so like voting for these reality TV shows or contests and things like that. It's just people volunteer to be part of the process. So watch for things like in TV voting, for example, if people could vote more than once, things like that, to try and sway the results. And the other thing to watch for certainly is if you're looking for like feedback for things, you tend to be more likely to get negative feedback about things than positive. Most people remember to do negative reviews, but don't necessarily remember to bother to do positive reviews, unfortunately. Kind of how it goes. So when you're looking at reviews of things on the internet, I always kind of try to keep that in mind. Plus also the idea of like bots, whatever, generating fake reviews is an issue too. But anyways, so sampling techniques, that's the topic for the day. And there's your practice questions. And that's it for now. All right. Thanks for watching. I'll see you next time.